So as we take a second look here at our systems of equations, we're going to start with graphing. We chatted a little bit, and I'm going to show you both ways with these two equations how we can graph these lines to get them on our graph here. So first thing we chatted about yesterday is the y-intercept is the first thing we have to deal with. Again, stressing the fact it's y. So that first point is going to go on the y-axis with very rare exception. Once we do that, we deal with slope. Now, for our slope in this case, here's the big thing we got to work on. I notice it's negative. That negative value can go on one of the two numbers. It does not matter which one, but it can only go on one. It doesn't go on both, because otherwise, negative times negative is positive. And so with slope, we're always doing rise, my up or down number, negative being down, positive being up, over run, my left or right. If it was negative, it would be left. But since it's positive, we go right. So a couple of things to note here. When I go to make my next point, I start at my intercept. 1, 2, 3, 4. Okay, we're going to be a little bit guesstimation here. And then 1, 2, 3, 4 to the right. But we always want to make sure we have at least 3 points and more if we can. Yeah.
Wouldn't the 5 over 4 be both negative since the 9 cents in the middle?
Okay. Since if they were both negative, though, and the question was, wouldn't these both be negative? Negative divided by negative would make that a positive slope. So it can only be on one of the numbers. You can choose which number it's on, but it can only be on one of them. Good question. And so let's say, though, you're like, well, wait a minute. If there's 3 points I have to have, how do I do one more point? And what we talked about yesterday is I have the option with my slope of flipping the directions of both of these if I need to. So what I could do, if I ran out of room, is go 5 up, 1, 2, 3, 4, 5, and 4 left, 1, 2, 3, 4. Because, here's my reason for that, doing negative 5 over 4 is the same thing mathematically as 5 over negative 4 would be. Okay? As long as the negative's only on one of the numbers, they're the same. And so, we're going to try and find some straight edge. Okay, again, a calculator would work here. Hopefully my boss isn't watching this going, you're using our $100 calculators as a ruler. Well, you know, we do what we got to do. So we get that first one in. Now, some of you may say, graphing lines, not my biggest strength. Is there another way? And there is when you're in class. We can go to the calculator to get some help here. So if this is a new thing to you, here's what we're going to do. We're going to go to y equals. And if there's stuff there already, and there may be, we're just going to hit the clear button, then arrow down, clear. So we're brand new cleared out here. And we're going to put this fraction in there. But here's the deal. I need to make sure that when I go to put this in the calculator, okay, that we put the negative 1/4 in parentheses. My x is the button up here next to alpha. And then I can put the +3. Always want to check your signs, because if we get the wrong signs in, that kind of makes a mess. And so, if I want to see what that will look like, I can kind of get a picture here. But here's what I want to check for. I'm going to hit second graph, because that's going to help me get some points. So what I typically do is, I'm only going to look for the whole numbers. I don't want to get all the decimal stuff going. So, negative 4, 4, 0, 3, 4, 2, and I've got my 3 dots, okay? So both would get us the same way. If I did my y-intercept and slope, I'd end up in the same spots. We'll show you that here in a second. Get our second line in here, and then we'll explain what the whole deal of this is. What's the point of doing this? Somewhere, when I'm making all these points in these lines, there's going to be a point where they intersect, where they have the same point. That's my answer. So when I go to try to find that, we're going to use a coordinate point, x and y. And so I'm going to see, to get there, I went 1, 2, 3, 4 to the left. I see the negative 4 on my x-axis. And I went up 1, 2, 3, 4. And that's my answer. So if I put every single dot I can on these, they will cross at some point, and I can find that value. So whether you use the calculator or whether you use the slope-intercept form, don't care, but they both can get us working towards that. So it gives us a little bit of an intro again on how that works. It's something new. More in-depth analysis, the video from yesterday would help there. Solving by elimination. Now here I want to chat for a second because there can be some things going on here. We chatted yesterday about how we normally are going to do some multiplying. I didn't mention one thing, and we're going to make note of that here. Check to see if a variable can be eliminated before multiplying. Now, does it mean if I don't do this and I just multiply right away that I'll get the wrong answer? No. But sometimes I may get lucky and save myself a lot of work just by taking a quick moment to look and say, hey, if I start adding down right away, will one of the variables disappear? And sometimes it may. So for instance, if I'm looking at number 5, I'm like, okay, negative 6 plus negative 9, that doesn't cancel out. 4 and negative 4. Ooh, 4 minus 4 is 0. 4 minus 4 cancels out. That's a good thing because we want to solve for a variable. And if one disappears, negative 6 minus 9 is negative 15. Don't forget my x. Negative 18 plus 3, again, we're adding down, is negative 15. And all of a sudden, just that quick, I've got a one-step equation to do. Okay? I'm multiplying by the negative 15. Don't add. We're not subtracting it. Get those canceled out. And just that quick, I've got one of my variables solved for, which is a good thing. Now, I'm not quite done because I still need to know what y is. So, to get y, again, we can plug into either equation. It doesn't matter which equation I plug my 1 in for x. Okay, so let's say we just do the top one. So negative 6, when I get to the variable that I know, I replace the x with the 1, and I copy everything else. So the only thing that changed in that equation, that first one, is the x value. And we saw in the first quiz, a lot of you do a really solid job when it comes to solving for these. I need to get y by itself. I'm minusing 6 from it. I got to do the opposite. And I get my y. So that, when we get fortunate, that can be one of the ways elimination helps us out quite a bit. We can make sure. Now, if we do what we do in another problem we're going to talk about here, do the multiplying, that still gets the right answer. It's just going to be a little more work. So Just something to consider. So speaking of that, when we flip over here, we're going to take a peek at number 6. And number 6 is a little different. 7 plus 14, that's not going to eliminate anything. Negative 5 plus 7, if I check that in my calculator, it's 2. That doesn't eliminate anything. So now we're going to do what we talked about doing yesterday, which is we're going to take these front two numbers. We're basically going to flip them over. So this started with 14. We're going to multiply the top one by 14. Okay? And here, the 7 was the number out front. And we're going to switch these. The only thing I've got to consider when I do that, so we're going to distribute through up here. The numbers are going to get kind of big. That's why I said a calculator is probably a good idea. Even for me here, let's see. I'm going to have somebody double check me. I think that's right, but I'm not 100% sure. Now, before I do the bottom one, here's the key. When we did the one on the front, we had opposites. When we added them, they cancel. If I do 7 times 14, this is going to be 98. But 98 plus 98 doesn't cancel. If that happens, we may have to change a sign on one of them. And usually I just do it on the second one after I check. So that's negative 98. And that negative number gets distributed all the way through. Alright. So, now that I've done that, again, I add down. 98 minus 98, goodbye x's. Negative 70 and negative 49. Again, we're adding. And I even need to double check on this one because I don't want to screw this up. And again, this last step is always going to be I'm multiplying by something. So my opposite is going to be to divide. And most of the time, they'll end up going in pretty nice. So notice this time we solved for y first. The first time it was x. It can vary up a little bit. So my last step, again, pick an equation. Doesn't matter which one. I usually will just kind of use the top one. 7, don't replace the x. Okay, that's not the one that we've solved for. It's the y. And now it's just the detail stuff. Okay, making sure that we get this down. Negative times negative is a positive 15. I'm trying to get x by itself, and again, I box that in because it reminds me, hey, whatever's with the box side, that's what I need to do the opposite of. So minus the 15. And divide by 7. Okay, they clean up pretty nice. So we've looked so far at graphing. When they're in y equals, we can plug them in the calculator. We can graph them with slope-intercept form. We've seen elimination, where we multiply both or kind of see if they cancel. Last one to go back over, okay, is number 11, substitution. From yesterday, what we're looking for here is, do either of my equations have an x or y equals already? If they do, here I see a y equals. What I'm going to do, since this says y equals, is I'm going to replace the y value in my other equation. So here's how that's going to work. I'm going to start copying that first equation until I get to the y. Because this, what's in the box, is now my y value. Everything else in that equation stays the same. The x term, the minus 4, the 16 on the equals side. We're going to clean this up So we're going to distribute the negative 4. Again, got to watch for the details. Negative times negative is positive. Negative times positive is negative. And now it's just watching for the basics, like my x's, they're on the same side of the equals. Don't do opposites with these. And we just go now into mode of what's being done to x, opposite of minus 32. Divide by 6. And again, here I could plug this into either one, but I will give you a word of help. If you plug it into the y equals 1, it's going to go a lot faster. So y equals negative 2. I know what x is now. Plus 8. Negative 16 plus 8 is negative 8. Now again, if you need more examples, things like that, there is a video up yesterday with some of these same things. Otherwise, kind of jumping in and doing the rest of them on this sheet is the assignment for today. But I want to